All right, 10.4 are reactions where a gas is produced. So we've talked about double replacement where liquids are produced. We talked about double replacement where solids are produced. Now we're going to talk about double replacement where gases are produced. And mostly it's the ones we're going to talk about are for carbonates, which we've done these in lab, and bicarbonates. First, I'm sorry, so carbonates, remember, have a CO3 2 minus, and bicarbonates, if you remember, is H CO3 1 minus. All right. So you can see in the examples here, we have a carbonate. All right. So these are types of double replacement reactions. I don't like how your book does this. They kind of put this after redox, even though this is technically a double replacement. So in your notes, just put this under the double replacement, in particular the acid-base section. This is a type of acid-base reaction. So notice you have HCl and sodium carbonate. If you do a double replacement reaction, the H goes with the CO3 and you get H2CO3. And then the sodium pairs up with the chlorine to get NaCl. All right, remember this 2 is here because we need 2 of these for every carbonate, but the ion is sodium plus. Okay, don't carry these numbers down. All right, in this case you have to because it's part of your polyatomic ion. All right, well, this is your product. So why is it not your product here? That's because this is carbonic acid, and carbonic acid is not stable in water. All right, it breaks down immediately into water and CO2. Okay, so it actually shows you here carbonic acid and NaCl. This is not stable. Okay, it breaks apart into water and CO2, which is a liquid and a gas. Okay, so anytime you form carbonic acid as your product, that is what's going to happen. You're always going to get water and CO2. So make sure you do not write this as your product because that's not correct. Water and CO2 are the products that you have to write. All right, so let me show you a very common reaction. I don't know if any of you have ever made a volcano. Usually people have, at least half a class has made the classic volcano, where you take vinegar, which is acetic acid. This is the chemical structure of vinegar, and you add sodium bicarbonate, which is baking soda. Okay, and this is also aqueous. So you take a baking soda, which is sodium bicarbonate, and vinegar, and what happens? You get bubbles, you get a volcano. Well, what do you think is happening? Well, the acidic hydrogen here is pairing up with the HCO3 to form, remember, H2CO3, which remember is not stable. It breaks down into water and CO2. And then your sodium pairs up with your acetate to form sodium acetate. Oh, I have those backwards. C2H3O2. So this is where the bubbles is coming from. This is where the volcano part is coming from. Okay, if you have never done this experiment, just go ahead and do it. I bet you have vinegar somewhere and sodium bicarbonate or a baking soda. Okay, if you don't, you can use Tums. If you have Tums laying around, Tums is calcium carbonate. Okay, the way Tums works, which is an antacid, it neutralizes the heartburn. Heartburn is basically when the acid in our stomach creeps up into our esophagus, and it basically starts burning the inner lining of our esophagus. Sounds great. I think heartburn is a pretty horrible name too, because it's not really heartburn. It's called acid reflux, which basically means the acid is going up into your esophagus and then it drips back down into your stomach, goes back up and drips back down. This process of going up and then back down, up and back down is called reflux. So in this case, you form calcium chloride and carbonic acid, which is H2O and CO2. That's why they say Tums is a good source of calcium, because that's where the calcium is coming from. Also, if you have really bad heartburn and you take a lot of it, I don't know if this happens to you, but like you start to burp a little bit. That's because you are forming a lot of CO2. So basically what you're doing is you're neutralizing. This is another neutralization reaction. That's why I called it an acid-base reaction. You are neutralizing the acid, so it doesn't burn anymore. Okay, so here's another sample problem. We didn't really talk about this. They didn't even talk about it in here. Actually, I do not want you to do this. We did not talk about this. So do not worry about this problem because we did not talk about the formation of SO2. But it basically is showing you that this compound H2SO3 breaks down into water plus SO2. Don't worry about this. Ignore this problem completely. And when we come back, I will talk about heat and chemical reactions.